Okay, let's have a go at this harder and longer question. We have a quartic function, and we're going to find the roots given that x take away 7 is a factor. Okay, so we already know that one of the roots is positive 7, and we're going to go straight into synthetic division using the coefficients 1, negative 4, negative 25, positive 16, and 84. Okay. So remember that we are adding vertically and multiplying diagonally. So 1 plus 0 is 1, times 7 is 7, add them, we get 3, times 7 is 21, add them, we get negative 4, times 7 is negative 28. Now, negative 16 plus negative 28 is going to be negative 12, and 7 times negative 12 is negative 84, which is a good sign that we've done it right, because this is coming out to be 0, which is what we expect. X to the power 4 becomes x cubed, x cubes become x squareds become x's, and our x's become constants, and our constant becomes our remainder, and we are now ready to find our next root to do synthetic division a second time. Alright, so this time we're looking for factors of 12. 1 and 12, 2 and 6, 3 and 4. It could be any of those. So looking at these numbers and their signs, I'm gonna just take a guess, and I think I'm gonna go a bit positive, a low positive to compensate for that big negative 12. Let's just try 2. It might not work, but it might. X equals 2. Okay, so putting 2 into this cubic function, and we get 2 cubed plus 3 times 2 squared minus 4 times 2 minus 12 is equal to 8 plus 12 minus 8 minus 12. Look at that. 8, 12, 8, 12. That comes out to be 0. And we can conclude that x equals 2 is a root, and we're ready to do some more synthetic division. So, multiplying diagonally, bring down the coefficients of this cubic, which is 1, 3, negative 4, negative 12. Adding vertically, 1 plus 0 is 1, times 2 is 2, add 3 is 5, times 2 is 10, add the negative 4 is 6, times 2 is 12. We knew this was going to come out to be 0. A cubic becomes quadratic, x to the power 2 becomes x to the power 1, x to the power 1 becomes our constant, and we can now say that this quadratic is also factorizable. I'm not going to use synthetic division, I'm just going to go ahead and factorize it, and this is going to come out to be x plus 5 and x plus 2, x plus 2 and x plus 3. And I now have all the factors. I've got 2 there, I've got x take away 2 from there, and I've got x take away 7. So I'm going to say the factors are x take away 7, x take away 2, x plus 2, and x plus 3. There you go. So that is finding factors of a quartic function. Good luck with your questions.